In today's video, we're going to be looking at reciprocal models, but before that, I just want to go through a few basics in terms of reciprocal functions. As you can see with the red lines on this graph, these are the major lines that are modeled by this equation here. So y equals k over x, where k is a constant in the example. They are referred to as branches. The other thing to note are our horizontal and vertical asymptotes, and those are when x equals 0 and y equals 0. The first example states that for a given mass of gas kept at a constant temperature, the volume, V centimetres cubed, varies inversely as the pressure, P units. Now, it's really important to note that it says inversely. When an example has the word inverse or inversely, we know that it is a reciprocal model, and therefore you should be using this particular formula. The graph shows this relationship for a particular type of gas. So part A says find the volume when the pressure is 80 units. So if we're finding, we're not calculating, and we don't have a formula as yet. So we're going to use the graph to be able to read for the other value. So we know that P equals 80, and what we're wanting to find is what V equals at that point. So we're going to find 80 on the graph, which is here, and then we're going to meet the graph, and then we're going to go across to volume. And as you can see, that's at about 5. So it is volume, so we've got to make sure we include our correct units. So when the pressure is 80, the volume is 5 centimetres cubed. For the second part of A, it says the pressure when the volume is 40. So this time we have our volume at 40, and we need to find the pressure. So this time we're going to 40 on our graph, and we're going to go across, and this time it's a little bit easier because it's on the lines. It's going to be a lot more of an accurate value. And so we can see that it's 10 units for that pressure. So when the volume is 40 centimetres cubed, the pressure is 10 units. So now using the graph, we're going to find the reciprocal function that models it. So we knew that the volume varies inversely with P. So we can write this here. And this looks very similar to that original reciprocal function. And with the original reciprocal function, we use K, which is our constant. Now what we want to be able to do is find a value for that constant for this particular example. And to be able to do that, what we're going to do is we're going to choose a point that we have already found on our graph. And that point is going to be this one here, where V equals 40 and P equals 10. Now that's a very accurate point because it actually sits on the line both ways. So we're going to use that to be able to find this constant value. So if we use this formula here, so V equals K over P, and we're going to substitute those values back in here. So 40 is K over 10. Now remember, we want to know what K is, okay, is to be able to find a reciprocal function for this. So if we rearranged our formula, then K would equal 400. So that tells us that that is the constant for this particular function. So the final answer for this is to now substitute this back into our reciprocal function. So our answer is V equals 400 over P. And that now is our reciprocal function for this particular set of data and this graph here. So using the reciprocal function just found in part B, which is V equals 400 over P, I'm just going to rewrite it here so we know what we're using. It says to find the volume when the pressure is 50 units. So this time we're not going to use the graph, we're going to actually use the formula. So here it's saying that pressure equals 50. So when P equals 50, we're going to find out what the volume is. So all we're going to do is substitute that value into our formula. So V equals 400 over 50. And if you put that in a calculator, or 450, that should just be 8. So the volume is 8 centimetres cubed when the pressure is 50 units. Part 2 of this section is to find the pressure. So now we need to find P. So find the pressure when the volume equals 60. So now what we're going to do is use our formula, but instead we are now going to find P. So our formula is V equals 400 over P. And I'm going to substitute V back in here, so that's 60 equals 400 over P. Now, what you want to be able to do is rearrange the formula using algebra, and so what you should get is P equals 400 over 60. So when it comes to this, you can either do it as a decimal or in this particular instance we want units, so we're actually going to do it as a fraction. So all we're going to do is simplify this fraction. So if I cancel those, 40 over 6, and then I could simplify using factors. So I would then simplify to 20 over 3 units. And this is a good way of doing it if you haven't got your calculator with you, but especially if you've just got units and you're not sure if they want it in decimal places, it's always good to leave it as a fraction answer. The next question says that the table below shows how the time, t, hours, taken to complete a task varies inversely, so again it's got that word inversely, with the number of workers n. So as you can see, they've now given us a table of values instead of a formula or a graph. So what they want us to do first is to plot the points to represent the data. So I've been able to do that using our online tool. So now using this graph, we are now going to use it to be able to find a reciprocal model or function. So just like before, we know that they inversely relate to each other. So we know that we can write that as t equals k over n. And just like before, what we're going to do is we're going to use one of these points to find the constant. So I might use the points 4 and 3. So here we've got where n equals 4 and t equals 3. And I'm just going to substitute that back in to find k. So 3 equals k over 4. And so if we rearrange it to find what k equals 12. And so now I have my constant for this particular relationship here. So my final answer is t equals, so I'm going to put back my constant back in there, so 12 over n. So this is now the reciprocal function that represents the table of values that we got initially. And this will allow us to now answer the rest of our questions. So I'm going to rewrite it for our next question. So t equals 12 over n, just in case we need to use it. So now it says to calculate the time that it would take 7 people to complete the task. So we know that t equals time and n is the number of people. So we're now going to substitute n equals 7 into our formula. So if I did t equals 12 over 7, and if I put that in my calculator, I should get 1.7. And the units for t was hours. So it would take 1.7 hours for 7 people to complete the task. Now part D, here says need to calculate the number of people required to complete the task in half an hour. So now we're going to use our formula again, t equals 12 over n. So the time now equals half, because it's half an hour. Okay, and remember the units are in hours. So this time what we're going to do is we're going to substitute that back in. So half equals 12 over n. Now, if we rearranged our formulas, what we're going to do, and I might just continue this over here, is the first thing is I'm going to multiply 2 on both sides. So I've got 1 equals 12 over n, and to be able to get rid of that 2, what I've done here is multiplied by 2, multiplied by 2. So now, sorry, I made one little mistake. If I multiply by 2, we cancel. So now I have 1 equals 24 over n. And what we want to know is the value of n. So if we rearrange our formula, we should get n equals 24. So now we know that there are 24 people that would be required to complete this particular task in half an hour.